right, let's start solving this problem. I claim it's an improper integral. To know why, you'd have to write secant of x is 1 over cos of x. And so I would have an issue if cosine is 0. And cosine of x is 0 whenever I'm at an x equals 0. And so that's, in my interval, going to happen at pi on 2. So at pi on 2, we don't have a continuous function. This means this integral is improper, and I cannot evaluate it with FDC. In fact, this is the example I started with, that area that looked like a chimney. I'm doing half of it right now. We'll do it all in a second. All right, so 0 to pi on 2, secant squared of x dx. This is my discontinuity, so I'm going to replace it by t. And I'm going to have a limit as t. I need more room. I'm going to replace it by t. So I need a limit sending t to pi on 2. Now I'm going to give you 5 seconds to determine if it's pi on 2 plus or pi on 2 minus. Yes, since it's the top bound, the bigger bound, I'm going to make it smaller so the interval shrinks. Don't want to make my interval bigger, that's just going to make my issue, well, not worse, just the same. So pi on 2 minus, because it's the top bound, I put a minus. This is going to give you the limit as t goes to pi on 2 minus. Now I can integrate this using FDC. And so I get the limit as t goes to pi on 2 minus tan of t minus tan of 0, which is 0. So now I need to figure out what happens to tan when t goes to pi on 2. Let me give you a quick graph. This is pi on 2. This is minus pi on 2. Between the two, the graph looks like this. And so if I'm going to pi on 2 from below, I'm going to approach plus infinity. All right, so this interval diverges to plus infinity. Now that we've done this, let's take a look back. I want to take a look back at this area here. Right, we'd set up the integral as the first example of improper integral of type 2. But of course we couldn't. And so when I wrote this, that was fine, that's the area. But now according to this, if I split it at pi on 2 like I'm supposed to, the first integral does not converge, and so the whole thing does not converge. As the integral from 0 to pi on 2 equals plus infinity. So really this area here from 0 to pi on 2 is already infinite, and this one will be infinite too, and strangely using FTC when we're not allowed, we can cancel those two infinite and we got 0.